Hey, Chemistry Crew, Mr. Collier here. Today I'm going to give you another gas law. This one's called the combined gas law, and it's often lovingly referred to as Choyle's law because it combines Charles and Boyle's law into a single law. And if you'll recall, Charles and Boyle's law were each about two of the gas variables at the same time. This one's going to look at how changing two can affect a third. So you're going to see when we look at the equation that there are three different variables. So the three variables we're going to look at are pressure, volume, and temperature. We're going to look at them all in a single equation. We're going to look at how either changing pressure and volume can affect temperature, or temperature and volume can affect pressure, and so on. If you'll remember, pressure and volume are how we relate Boyle's law, and volume and temperature are how we relate Charles' law. And now we can look at how changing any two of those will change the third. And so the equation is really just those laws smushed together. P1 V1 over T1 equals P2 V2 over T2. And we're going to look at how you would do this. So here is another example in your packet. And here we have a gas that occupies 72 milliliters at 25 degrees and 198 kilopascals. Convert these to standard conditions. What is the new volume? So here we have a gas that's under a certain temperature and a certain pressure, and now we want it to be standard temperature and standard pressure, and see how that's going to affect the volume. So first, let's write down what we know. We know the starting pressure is 198 kilopascals, the starting volume is 72 milliliters, and the starting temperature needs to be in Kelvin, so we're going to add 273 to get 298 Kelvin. Now we're going to convert it to standard pressure. Well, pressure is 101.325 kilopascals. That's that 1 atmosphere, that's standard pressure. Volume is what we don't know, and the standard temperature is 273, 0 Celsius. Now we're going to plug these values into our equation, P1 V1 over T1 equals P2 V2 over T2. And now we simply need to cross multiply and solve for V2. So 273 times 198 times 72 equals 298 times 101.325 times our volume. Our units are all going to cancel except for our milliliters of volume, and we'll have our final volume. Another thing that you might want to do is try to think about, does this make sense? This can get tricky here because we're often going to be doing different things, changing both pressures and volumes and temperatures, and it can get a little bit tricky there, but it still doesn't hurt to think and see if it makes sense. So here it was under a little bit more pressure, right? So our new condition is a little bit less pressure, and our new condition is a little bit cooler, right? So in this case, both of these things, less pressure and less temperature, will both go toward making the gas expand and take up more space. So our final volume being larger actually makes a lot of sense. So with that, you should be able to do the sample problems that are going to be in your homework on the combined gas laws. Let me know if you have any questions.